Okay, let's keep things going with our trigonometry and look at some trig ratios that we need to know, potentially without our GEC. Two things that you're going to need to learn for this, and it's two triangles fundamentally. So one is an equilateral triangle. Let's have a little play here. Okay, so an equilateral triangle. With side length of 2. So this equilateral triangle, I'm sure I've got something that could draw it much better than that on this app, but there we are. It's an equilateral triangle, side length 2. Now the important point obviously with the equilateral is the angle size, and we're doing trig here, so we're interested in angles quite often. This angle is going to be, shall I stay in degrees? I think a lot of you prefer degrees. Let's stay in degrees for a little bit. We'll call this 60 degrees. And so what we do from there is we split our triangle down. Remember, this side length is 2, and we can then just take that left hand side of the triangle out. So I wanted that 2 there. So let's just take this triangle here. So now I've got this triangle, just the left hand side of it, and we can start to label this. So it's 60, 90 and 30. Side length 2. The bottom bit here was cut in half. So this is 1, and using Pythagoras I can do the square root of 2 squared minus 1 squared, which is root 3. Okay, so now we're just going to use our SOHCAHTOA, and the sine of, for instance, sine 60 equals the opposite over the hypotenuse, root 3 over 2. The cosine of 60 is the adjacent over the hypotenuse, 1 over 2, and the tan of 60 is equal to opposite over adjacent, root 3 over 1, which is just root 3. Now obviously we've got more that we can look at here, because we've also got this 30 degrees labelled, so we can look at the trig ratios at 30 degrees. So let's go with this. So starting again, sine 30 equals the opposite over the hypotenuse, 1 over 2. The cosine of 30 equals the adjacent over the hypotenuse, root 3 over 2. And the tangent, the tan at 30 is equal to opposite over adjacent, 1 over root 3. Give myself a bit more space. 1 over root 3, which we can rationalise to be root 3 over 3. So you do need to be able to show an exact form, the sine, cos and tan of 60, which are these three, and I have never learnt these. I wouldn't learn these, I would just learn how to derive them. And the sine, cos and tan of 30, which are these three here. Now I did say at the start there's 2 triangles that you need to know, so let's have a look at the other one. Not with that, but let's go back up and go next to this, and the second one we're going to use an isosceles. I'm going to call this 1 right angle, which means both of these are 45 degrees, 45 degrees. Okay, so there is only one angle on this one that we can use, so we're going to use the sine of 45 which is simply our, oh hang on, I haven't labelled the hypotenuse, have I? So 1 and 1, using Pythagoras, this hypotenuse is root 2. So sine of 45, opposite over the hypotenuse, 1 over root 2, or root 2 over 2. Cosine of 45 is, now I'm looking at this 45, it's the adjacent over the hypotenuse, it's the same thing. Root 2 over 2, and the tangent of 45 is the opposite over the adjacent 1 over 1, which is 1. So there we got it. We got 9 trig ratios that we're able to describe, or able to work out the exact form of. So let's look at what type of question you might be asked to do. I'll write this out here, and we can say find the exact value of x in this triangle. So find the exact value of x in a triangle that I'm about to draw for you. So we've got right angle triangle, we've been given that this is 60 degrees, and we've been given 5 and x. So we're not able to use our GDC for this. We're going to identify first of all which of our trig ratios we're using. Opposite and adjacent, so that's going to be tan, so I can say that tan of 60 equals the opposite over the adjacent, but I know from what we've just worked out what the tan of 60 is. Oh, I'm not supposed to move that. There we are. Tan of 60 is here, it's equal to root 3. Done the same thing again, here it is. So that thing here, x over 5, needs to equal the square root of 3, which means x is equal to 5 root 3. And there it is in exact form. Don't plug it into your calculator, you'll undo all the good work you've done. We're finished at that stage.